Welcome back. Episode 4 gave knowledge a lint pass, check the rulebook, fix the conflicts, ship it. Today the stakes rise, because today the agent's output is not a document, it is an action, aimed at physical equipment, with consequences that do not offer an undo button. This is the guard station of our series Spine, the episode the whole journey has been walking toward. One sentence carries it all. The LLM writes the proposal, and Z3 holds the veto. What actually changes when we move from linting a knowledge base to guarding a live system? 3 things, and each one reshapes the engineering. First, the clock. A lint verdict feeds a meeting, humans read the core, argue about precedents, choose a fix. A guardrail verdict feeds an actuator, and the answer must arrive before the control cycle ends, milliseconds, not meetings. Second, reversibility. A bad clause underpays someone, and that is serious, but it is recoverable. You back pay, you apologize, you fix the rule. A bad setpoint that suffocates the biology in a treatment tank, or breaches a discharge license, is a different category of mistake. Some consequences do not have an undo. And third, duration. Linting is an event, you run it, it finishes. Guarding is a condition. Every proposal, from every proposer, human or model, passes through the same gate, on every cycle, including the one at 3 a.m. that nobody is watching. The comforting part, it is the same 10 constructs, the same unsat core. Only the job description changes. Our main case comes from a domain I have worked in for years, wastewater treatment, specifically the aeration stage. Giant blowers push air into the tanks to keep dissolved oxygen, due for short, high enough for the microbes that do the actual cleaning. 3 facts set the scene. The biology is fragile. Let dissolved oxygen fall too low and the microbes suffocate. Recovery takes days, and while the biology recovers, untreated water keeps arriving. It is the kind of failure that compounds. The license is strict. Discharge quality is regulated, and a breach is not a bug ticket you triage on Monday. It is a reportable incident, with penalties, and with a community downstream. And the bill is enormous. Aeration commonly accounts for around half of a treatment plant's entire energy cost. Which is exactly why every optimizer you point at this plant, a reinforcement learning policy, an LLM copilot, an eager engineer, keeps proposing the same thing: turn the blowers down. So the incentive points one way, the biology's tolerance points the other, and someone has to hold the line. That someone is today's subject. The central object of this episode is the safety envelope, the set of states and actions the plant is permitted to occupy, written down as constraints. Ours has 3 layers, and the layering matters. Physical limits describe what the equipment can do at all. Our blowers run between 40 and 100%. A proposal outside that range is not even unsafe, it is fictional, and the envelope should say so before anything else reasons about it. Regulatory limits describe what the license demands: dissolved oxygen never below 2.0 mg per liter. This line is non-negotiable, and it is the reason the shield exists. And rate limits describe how fast anything may change, setpoint moves capped at 15 points per cycle. Slow physical systems punish sudden ambition. A change that is safe as a destination can be dangerous as a jump. Geometrically, the envelope is a box in the space of states and actions. Inside the box, allowed. Outside, veto. And organizationally, it is treated exactly like Episode 4's knowledge base, compiled once, reviewed, versioned, and then consulted on every single action. Here is the architecture, and after 4 episodes you could draw it yourself. On the left, the proposer, a reinforcement learning policy, an LLM copilot, sometimes a human operator. The shield is deliberately agnostic. In the middle, the gate, the shield takes the current sensor state, the envelope, and the proposal, files them all as constraints, and calls check. On the right, the actuator, the real plant, which only ever receives what the gate has passed. Watch the traffic. Most proposals are fine. Sat, pass, execute, next cycle. But when the verdict is unsat, two things happen, and both matter. First, the veto is logged with its unsat core, the receipts, exactly as in episode 4, naming which envelope clauses the proposal violated. Second, the plant still needs an action this cycle, you cannot actuate a refusal. So the shield applies a fallback. And here is the elegant part, courtesy of Construct 10. The fallback need not be a dumb preset. Optimize can synthesize it live, the least cost action that still sits inside the envelope. Veto with receipts, repair with proof, in the same solver call family, in the same handful of milliseconds. The envelope in code, 14 lines between the language model and the blowers, and every construct is from episode 3. Two unknowns, A, the proposed aeration setpoint, and do_next, the dissolved oxygen we predict one step ahead. Two live sensor readings enter as constants, DO is currently 1.8, and the previous setpoint was 55. Then the envelope, each clause tracked under a name. E1, equipment bounds, 40 to 100. E2, the interesting one, a one-step model of what the action does to oxygen, simplified here to a linear rule, conservative in practice, and versioned like any other piece of knowledge. E3, the license floor, due at least 2.0. E4, the rate limit, 15 points per cycle. E5, a peak hour energy cap. And then the move that makes this architecture click, the LLM's proposal, cut aeration to 45, is filed exactly like any other claim. Assert and track, name it P. The proposal gets no special status, no benefit of the doubt. It is one more statement that must coexist with the law. Check decides whether it can. Let me run one real control cycle for you, timestamps and all. Run the tape. 21:14 and 3 seconds, plus 120 milliseconds, the proposal arrives. Demand is low tonight, cut aeration to 45% and save energy. Fluent, plausible, economically sensible. And pointed straight at the floor. 9 milliseconds later, the verdict, unsat. And look at the core, E2, E3, and P, the model, the floor, and the proposal. From oxygen at 1.8, a set point of 45 drives the one-step prediction to 1.05 mg per liter, well under the license floor. Notice, just as in episode 4, who is not named, the equipment bounds, the rate limit, the peak cap, all innocent, all excluded. The judgment is surgical. 12 milliseconds after that, the repair, optimize synthesizes the least energy action that still satisfies every clause, 64%, projecting oxygen to exactly 2.0. The plant never felt the bad idea. 21 milliseconds end to end. And in the audit log, the proposal, the core, the fallback. Receipts for a 3 a.m. decision that nobody watched, until the auditor asks, months later, and the answer is simply, here. Now the subtlety that clause E2 smuggled past you. The shield did not just check the action, it checked the action's predicted consequence, one step ahead. That prediction requires a model of the world, and models, as episode 1 warned, can be wrong. 2 working defenses. First, be conservative. Choose worst-case coefficients, assume the sluggish tank, the tired blowers, the warm day when oxygen transfers poorly. The asymmetry justifies the pessimism, a conservative model that vetoes a genuinely safe action costs you some energy, while an optimistic model that passes a genuinely unsafe action costs you the license. When the errors are that lopsided, you buy insurance with conservatism. Second, screen candidates fast, and hear push and pop from episode 3 start earning a salary. A well-built proposer does not send one action, it sends 3 candidates. The shield pushes the first, checks, pops. Pushes the second, checks, pops. 3 disposable thought experiments inside a single control cycle, and the best survivor goes to the actuator. 1 step ahead is a shield. Many steps ahead is a plan, and verifying whole plans is exactly what episode 6 is for. Is this a wastewater story? No, and this is the point of the whole series. Keep your eye on the shield, and watch the scenery change behind it. Regulated fuel storage. Underground tank systems live under detailed storage regulations, tank level bounds, mandated leak test intervals, delivery cutoff rules. Compile those regulations into an envelope, and every scheduled delivery, every gauge-driven action, passes the same gate before anything physical happens. Aviation decision support. Safe landing advisories operate under weather minima, runway length and surface constraints, aircraft category rules. An advisory that violates the minima is never displayed, it is vetoed upstream, core logged, exactly like our blower setpoint at 3 a.m. And a preview, clinical dosing. Dose bounds and contraindications fit today's pattern directly. But the clinically meaningful guarantees, like limiting how much time a patient's glucose spends below range, are statements about whole trajectories over time, not single actions. That extra ingredient is precisely where episode 6 picks up. Different regulators, different physics, different failure modes. Identical architecture, envelope compiled from the rules, every action through the gate. Every time I present this architecture, the same sensible objection arrives: why not just tell the language model, firmly, in the system prompt, to never propose unsafe setpoints? 3 honest answers. First, a prompt is a suggestion, a constraint is a law. Instructed behavior shifts with phrasing, with context length, with the next model update, with a cleverly worded request. The envelope does not care how persuasive anything was. Second, probabilistic compliance versus deterministic verdicts. Usually refuses unsafe actions is a statistic, and a good one to improve. But check returning unsat is a proof, the same proof, every run, independent of temperature, mood, or moon phase. Licenses are not written in probabilities. Third, silent failure versus auditable refusal. When prompting fails, you find out at the actuator, or in the incident report. When the shield vetoes, you get a time-stamped core naming exactly which clauses the proposal violated, evidence, not vibes. So, to be completely fair to prompting, do it. Better prompts make better proposers, fewer vetoes, smoother operations. But prompting tunes the advocate. It cannot replace the judge. Use both, and never confuse them. The honesty slide, as always, and today it has 4 entries. 1. Sensors can lie. The shield trusts the number it is given. If a fouled probe reports healthy oxygen while the real tank suffocates, the gate reasons perfectly about a fiction. Sensor validation and redundancy live outside the solver, and no amount of logic replaces them. 2. The model is chosen. Clause E2 is authored physics, conservative, versioned, reviewed, but authored. Dynamics nobody wrote down pass through the gate unexamined. This is episode 1's modeling gap wearing a hard hat. 3. Fallbacks are themselves safety critical. The veto path executes precisely when the situation is already strange, which is the worst possible moment to run untested code. An unverified fallback does not prevent the accident, it relocates it. Ours is synthesized inside the same envelope, so it passes by construction, make sure yours does too. 4. Too tight costs real money. An over-conservative envelope vetoes genuinely good actions, burns energy, and teaches operators to resent the shield. Calibrating tightness against operating data is a genuine research problem, and we treat it as one rather than pretending a constant is a policy. A shield narrows the failure surface. It does not abolish engineering. 3 ideas to carry forward. 1. Guarding is a condition, not an event. Every proposal, from every proposer, passes the same gate, on every cycle, indefinitely, including the ones nobody watches. 2. Veto, then repair. An unsat core is a diagnosis, optimize turns it into treatment, synthesizing the least cost action still inside the envelope, in the same handful of milliseconds. 3. Prompts tune, constraints bind. Improve the proposer all you like, only the symbolic gate makes guarantees, and confusing the two is how incidents happen. Next time, the shield learns to think further ahead. Episode 6, Thought Experiments, Verifying Whole Plans and Simulated Futures, from the push-pop sandbox to constraints on entire trajectories, including the glucose control guarantee I previewed today, bounding not just a dose, but how much time a patient spends below range. The judge, it turns out, can read the future, carefully. See you then.